to be a mixture of rock and ice. And Callisto, probably the oldest of the four. The Voyager's next assignment was to fly by Saturn and its moons. Saturn's vast ring system is made up of many small particles that orbit the huge planet in wave-like patterns. Its atmosphere is buffeted by a strong jet stream that blows eastward at 1,200 miles per hour. Voyager detected the hottest gases ever observed in the solar system, up to 1 billion degrees Fahrenheit. As of now, 2/3 of the planets in our solar system have been explored, and by the end of this decade, we will have explored most of the rest, including Uranus and Neptune. Through the years, the single most constant in NASA has been, is now, and continues to be its aeronautical research. It is a common thread that is woven throughout the agency. It has influenced everything that flies, both on Earth and in space. There is little doubt why this country has been the world leader in things aeronautical. Here are some of the goals of the program. Make aircraft more energy efficient. Fly higher, faster, and farther on less fuel. Lower pollution. Systematic improvement of engine components. Reduce weight through use of light but very strong composite materials. Study problems associated with wake vortices, tornado-like patterns of air that trail off behind jet aircraft, causing problems for smaller planes following closely in their wake. Airplanes are America's leading industrial export, thanks to NASA's research and development programs. Since there are some 200,000 general aviation aircraft in this country, NASA research is also improving this class of airplanes. Crashworthiness and stall spin studies are good examples. Ice formation is also being worked on. The heart of this research is a unique refrigerated test tunnel capable of simulating the icing conditions an aircraft is likely to encounter. Once a test has been run, newly developed computer codes are used to evaluate the results. During the early days of manned spaceflight, consideration was given to using a parawing to return astronauts and spacecraft to Earth. While this method was ultimately discarded, it did produce a rather interesting new sport. There has been extensive work done on planes that take off and land vertically. and oblique wing craft that reduce air drag by pivoting the wing at various angles to the plane's fuselage. The expertise used to make airplane propellers better has also been applied to powerful wind turbine electric generators, including some of the largest in the world. NASA's aeronautical research was the seed from which the space program would grow. A prime example of this was the Lifting Body project that began in the early 60s. The combination of wind tunnel tests and actual flights led to the design of the reusable space shuttle. When the design and wind tunnel work was complete, a series of approach and landing tests were scheduled. Since the orbiter has no power for landing, its ability to land easily with only one try was critical.
Gears coming. Static gear coming. Gears down. 30 feet. 20 feet. 10 feet. 5 feet. 4 feet. 2 feet. 1 foot. Down.
The Enterprise's near-perfect landings gave final proof that the shuttle orbiter was a flyable, landable craft. The years of research and development would now be put to the ultimate test, the first flight into space of Shuttle Columbia with astronauts at the controls. There was an air of excitement as the brand new shuttle moved from its processing facility at the Kennedy Space Center to the vehicle assembly building, where it would be mated with rockets and fuel tank and rolled out to the launch pad. Never before had a new spacecraft been flown this way. Previous Mercury, Gemini, and Apollos were man-rated in advance, meaning that unmanned flights were flown before putting an astronaut crew on board. Despite nagging problems with engines and protective tiles, there was a quiet optimism. Longtime space workers knew from past experience with the lunar landing program that design and engineering problems do get worked out. After one false start, astronauts John Young and Robert Crippen headed for the launch pad.
30 seconds. That goes into the interior, and the astronauts are
Columbia's maiden flight would be brief, just 54 and a half hours, 36 orbits, and return to Earth. But it signaled the beginning of a reusable space transportation system.
To ensure that everything is in the proper place. 10, 9, 8, 7, 6, 5, 4. We've gone from 8 engine start to Roger, Columbia. You've got your normal Capcom back now. Okay. The only bad part about it, Joe, is we're going to have to come down.
Later, after Columbia had been returned to the Kennedy Space Center, cleaned, refurbished, and rolled out to the pad, astronauts Joe Engle and Dick Truly flew Columbia into space again. While an imaging radar system mapped distant Earth, the crew made a critical test of a Canadian-developed mechanical arm that would later place payloads into and out of orbit.
Okay, we copy. Thank you.
Looks like it's a little cloudy out here, Sally. It's a good thing the Sir AC's did that. And we can hear it crank up on the board.
Okay, stand by. Okay, we see fan A on, and we'd like you to take Bravo.
As Columbia landed the second time, the circle was complete. A new generation of space travel had begun. Space Shuttle 3 left the launch pad, it carried an experiment prepared by 18-year-old Todd Nelson of Rose Creek, Minnesota. An experiment to study the effects of weightlessness on insects in space. It's called the Shuttle Student Involvement Project and includes NASA, the National Science Teachers Association, and industry sponsors who help transform winning proposals into flight experiments. Since this first flight, young people in high schools around the country have developed and flown a variety of experiments, ranging from medical projects to the study of zero gravity on an ant colony. They are setting an example for others who may be encouraged to pursue careers in science and engineering, something that ultimately can be translated into technological leadership for the U.S. 12 weeks passed. Then, astronauts Ken Mattingly and Henry Hartsfield piloted Columbia on its fourth and final test flight. The spacecraft's performance made it possible to certify the Space Transportation System a fully operational carrier. As they landed on July 4th, the crew was greeted by President and Mrs. Reagan. First operational flight. 2 commercial communications satellites were hauled into orbit, one for satellite business systems and one for telesat.